Properties of fibers. Textile products play a vital role in meeting man's basic needs. We often only consider textiles to be the clothes we wear. Obviously, the clothing industry is where the majority of textiles are produced and used. However, textiles are also important in all aspects of our lives, such as agriculture, architecture, medical field, etc. The most common use of textiles is for clothing. In the household, textiles are used in carpeting, furnishing, window shades, towels, table covers, bed sheets, handkerchiefs, cleaning devices, and in art. In the workplace, they are used in industrial and scientific processes such as filtering. Some other uses include tents, flags, nets, kites, sails, and parachutes. Technical textiles are used for industrial purposes. For automotive applications, medical textiles, example implants, geotextiles, reinforcement of embankments, agrotextiles, protective clothing, example against heat and radiation for fire retardant clothing, against molten metals for welders, stab protection and bulletproof vests. All these uses are based on some special characters of textile or textile fibers. Textile fibers. Fibers are hair-like substances found in nature or made by man. There are a lot of fibers in nature. The best example for a fiber is the coir or coconut fiber. We are familiar with this fiber. Similarly, there are other fibers from plants and animals. Examples for fibers are coir, hair, cotton, pineapple fiber, banana fiber, wool, silk, etc. Fibers may be natural or man-made. Vegetable fibers, animal fibers, mineral fibers, etc. comes under natural fibers, while synthetic fibers, polymer fibers, metallic fibers, etc. comes under man-made fibers. Examples for fibers are fibers from the stem, flax, hemp, jute, etc. Fibers from leaf, bananas, agave, palm, etc. Fibers from seed, cotton, soya, etc. Fibers from fruit, coir. Fibers from grass, bamboo, totora, etc. Fibers from wood, hardwood, softwood, etc. Animal hair, wool, camel hair, rabbit hair, etc. Animal secretions, silk, spider web, etc. Biological fibers, collagen, actin, etc. Synthetic fibers, nylon, polyester, terylene, etc. Mineral fibers, copper, gold, silver, etc. But for the production of textiles, only few of these are used. Coir is a fiber obtained from coconut, but it is not used in textile industry. These fibers are used for making ropes and floor mats, etc. Cotton is another fiber which is widely used in the textile industry. The fibers that are used for textile production are called textile fibers. Some properties of these textile fibers makes them suitable for the production of textile. Textile fibers are those which have properties that allow them to be spun into yarns or directly made into fabric. So, all textile are made of fibers, but not all fibers can be used to make textiles. For example, cotton plants contain fibers that are strong and pliant enough to be spun into yarn. On the other hand, coir are technically fibers but are very thick fibers. So, they are unsuitable for textiles. Each fiber has its own qualities and will result in a different textile. The fibers come under same categories such as vegetable fiber, animal fiber or synthetic fiber may have same properties and can be used for similar uses. So, for achieving the finished textile with desired quality requires an understanding of the best fibers for the job. But how do we determine which fabric is suitable for the article we intend to develop? It is the properties that define a fiber and in turn the fabric. Properties of textile fibers are primary properties and secondary properties. Primary properties. Primary or essential properties are those properties that a textile fiber must possess to qualify as a textile material. The essential or primary properties of a textile fiber includes high length to width ratio, tenacity, cohesiveness or spinning quality, flexibility, uniformity. High length to width ratio. It is the ratio between the length and width of a textile fiber. For any fiber to be spun to made to yarn and then into fabrics, their lengths must be more than their width. The minimum ratio is 1:100. This means that the measure of the length should be at least 100 times more than the measure of the width. The length of fibers is also a basis for classifying them into two groups, staple and filament fibers. Staple fibers are short-length fibers and generally obtained from the natural resources except for silk and are measured in centimeters or inches, while filament fibers are long-length fibers and are measured in meters. The width of a fiber refers to the diameter. This is measured in microns and determines the fineness of fibers. Finer fibers are softer, more pliable, and have better drapability. When we consider the length to width ratio of fibers, cotton has a length to width ratio of 1400, whereas flax has a ratio of 170. Coir has a ratio of 83. Wool has a length to width ratio of 8000. Silk has a length to width ratio of 3,30,000. Tenacity. Tenacity refers to the strength of the textile fiber. It is the force required to break the fiber. Each fiber must possess a certain amount of strength to be able to bear the mechanical and chemical processing that it undergoes during the manufacturing process. Every textile fiber possesses varying levels of strength. Some possess higher strength and some possess lower. Also, the strength of textile fibers varies in the dry and wet state. For example, cotton is stronger when wet as compared to wool, which is weak in the wet state. Raw cotton has a tenacity of 3.0 to 4.9 grams per denier, whereas flax has 2.6 to 7.7 grams per denier. Jute has a tenacity of 3.0 to 5.8 grams per denier. Wool has 1.1 to 1.7 grams per denier. Silk has a tenacity of 2.4 to 5.1 gram per denier. And polyester has a tenacity of 4.4 to 7.8 grams per denier. Spinnability or cohesiveness. Cohesiveness is the property of the fibers to adhere to each other during the yarn manufacturing process. The process of spinning makes the fiber surface resistant to friction, and it is this lack of mobility that enables the fiber to stick together when being spun into yarns. There are some inherent irregularities in the longitudinal or cross-section of the natural fibers which permit them to hold to each other during fiber arrangement. Wool has an inherent crimp and scales on its surface that imparts a high degree of cohesiveness. Cotton fibers, it exhibits its cohesiveness by its cross-sectional structure. The kidney-shaped structure of a cotton fiber enables it to adhere to or fit into another fiber, thus sticking together during yarn manufacturing. Flexibility. Flexibility is regarded as how much flexible or pliable a fiber is in order for it to be made into yarns and thereafter into fabric for easy movement. Textile fibers must be pliable. Only then they can be spun with other fibers. Many substances in nature resemble fibrous forms but cannot be practical textile fibers because they are stiff and brittle. Uniformity. Uniformity is an important property of fibers because it is even yarns that make fabric uniform in appearance and consistent performance. Synthetic fibers are far more uniform than natural fibers. Uniformity is inherently difficult to achieve in natural fibers as they are procured from natural resources such as sheep hair, silkworm, seed hair, etc. Secondary properties. Textile fibers might possess few of these secondary properties and not necessarily all of them. Properties increase the value of textile fibers in its intended use. Secondary properties include physical shape, luster, elongation and elastic recovery, resiliency, moisture absorbency, thermal behavior, chemical reactivity, and abrasion resistance. Physical shape. The physical shape of the fiber is an important factor in determining many of its properties. It includes the surface contour, smooth, rough or serrated, the shape of cross-section, and the width and length of the fiber. The surface contour in turn influences cohesiveness, resiliency, loft, and thickness. Each textile fiber has its own physical shape. Natural fibers have surface irregularities, while the shape of the synthetic fiber depends on the shape of the spinneret or mold through which it is extracted. Cotton has a spiral or twisted ribbon-like appearance. Mercerized cotton is smooth and cylindrical and has fewer convolutions. Linen is smooth and bamboo-like with cross-marking nodes, no lengthwise striations. Silk is smooth and triangular shaped, transparent rod. Wool has a cylindrical, irregular and rough surface. It has a scale-like structure. Polyester is smooth, cylindrical with uniform diameter and rod-like appearance. Nylon has uniform diameter and rod-like appearance. Luster. It is a shine or ability of a fiber to reflect the light. Textile fibers can be shiny, moderately shiny, or even dull. Luster of a textile fiber very often depends on its physical shape. Silk fiber has a smooth structure, and when the light falls on a smooth surface, it reflects. Hence, silk looks shiny. Cotton fiber has an irregular structure and it does not reflect the light falls on it. Hence, cotton looks dull. Man-made fibers like polyester, nylon, etc. are produced with luster controlled. It is not always desirable to produce bright fabrics or dull fabrics. So, the luster is controlled by the addition of pigments such as titanium dioxide in spinning solution. The luster in natural and man-made fibers can also be improved by various finishing techniques. For example, the luster in cotton is improved by mercerization. Elongation and elastic recovery. Elasticity is defined as the ability of fibers to return back to original shape after being stretched. Elastic recovery is the ability of fibers to return from strain and is expressed in percentage. If a fiber returns to original length after stretching to a specified length, it is said to have 100% elastic recovery. Elasticity is required in fabrics when subjected to stretch during wear. Some fibers show immediate elastic recovery and some fibers may show delayed elastic recovery. Wool, silk, viscose and nylon are having good elasticity. Cotton and acetates have poor elastic recovery. Polyester has moderate elongation but has good elastic recovery. It is apparent that both the elongation and elastic recovery are considered together in evaluating fibers, yarns and fabrics. Resiliency. The property of the fabric to return back to its original position after being creased or folded is called resiliency. It indicates the crease recovery and elastic recovery of the fiber. Polyester, wool and nylon shows excellent recovery. Fibers such as flax and cotton have low resiliency. Moisture absorbency. Textile fibers generally have some amount of moisture or water content as an integral part of them. Almost all textile fibers are naturally hygroscopic, but the amount of moisture that the fibers absorb may differ. Absorbency is the ability to take in moisture, and moisture regain is the percentage of moisture a bone-dry fiber will absorb from the air under the standard conditions of temperature and moisture. Fibers that absorb water easily are known as hydrophilic, water-loving fibers. Fibers that have difficulty in absorbing water are known as hydrophobic fibers. Cotton, linen, wool, silk, rayon and acetate are hydrophilic fibers. Synthetic fibers like polyester and nylon have low absorbency. Absorbency is an important factor in all textile fibers, especially those which are used for apparels, as it influences fabric qualities such as warmth, comfort, water repellency, static buildup, dyeability, shrinkage, wrinkle resistance, etc. It is easy to wash a hydrophobic fabric as it does not absorb stains and it dries quickly. Fibers with good moisture regain and moisture content will accept. The absorbency of a textile fabric is controlled by the type of yarn and fabric construction and also by finishing. For example, in cotton, the absorbency is increased by care boiling, mercerization and napping. Pile construction increases the area of absorption. Thermal behavior. The thermal behavior of fibers is also an important factor for determining their performance and care. It is a reaction of textile fibers to heat. Textile fibers should withstand temperature used in processing. Flammability is an important aspect of thermal behavior. Among the textile fibers which are in use, some are heat sensitive and some are not heat sensitive. Heat sensitive fibers is also known as thermoplastic fiber. All synthetic and acetate are thermoplastic fibers. We feel comfortable when we wear some garments and we feel hot with some other garments. This is mainly due to the heat conductivity of fabrics. Heat conductivity is the ability of fibers to conduct away heat from the body. This is also an important factor since it contributes the use of certain fabrics in a particular season. Cotton and linen are good conductors of heat and can withstand high temperature. Silk and wool are bad conductors of heat and cannot withstand high temperature. Synthetic fibers like polyester and nylon are thermoplastic fibers. Chemical reactivity. The reaction of fibers to various chemicals is helpful in the use and care of fabrics. Chemical reactivity is the effect of acids, alkalis, oxidizing agents, and solvents. It is vital to understand the chemical composition and reactivity of fibers, since the manufacturing and processing of fibers involve the use of chemicals. The fibers with same chemical composition react in a similar manner when reacted with acids, alkalis, and organic solvents. For example, cellulosic fibers are fairly resistant to alkalis but get harmed with acids. Abrasion resistance. When a fiber is worn out or damaged or being rubbed against another substance, it is referred to as abrasion. It is the ability of fibers to withstand the rubbing or abrasion it gets in everyday use. All fabrics, irrespective of the end uses, are subjected to rubbing of some kind during wear. The fabric has to withstand rubbing, otherwise, the fabric will show signs of damage and become unsightly. The size and uniformity of the yarn also influences the abrasion resistance. Thick yarns resist abrasion than thin yarns. Irregular yarns are abraded more easily than uniform yarns. Nylon has excellent resistance. Acetate and glass have very poor abrasion resistance. Silk and wool has fair abrasion resistance. Cotton has better abrasion resistance. This is an important property as it influences the durability and increases the resistance to splitting. Knowing these different properties of fibers helps to understand the role of fibers in our society, including why different fibers are chosen for different applications, why fiber properties vary under different conditions, wet versus dry, knotted versus straight, and how natural and synthetic fibers compare. This makes a better selection of fabric for the designing purposes and personal uses.